Welcome to Rawmachines, a journey to discover the most impressive processes around the world. In today's episode, we will step into three different worlds: the modern scale of Sierra Pacific, US, the craftsmanship spirit of Britain lumber, New England, and the peak of automation at Dorataya Sag, northern Sweden. How will the journey of wood transform in these three very special sawmills? Join me to discover it now. Amidst the fresh air of the Oregon forests, where Douglas fir trees have stood firm for centuries, the loggers begin a new workday. Here, every tree trunk is a chapter in the Earth's chronicle. Each annual ring tells of harsh winters, dry summers, and the peaceful years the forest has endured. As the harvester machine moves in, the quiet of the forest is broken. The hydraulic cutting head reaches out, grips the trunk, and the circular saw blade spins rapidly. In just a few seconds, a 40-meter-tall pine is brought down, its branches falling heavily, and the trunk is precisely cut into segments. All of this occurs with near absolute precision, a mechanical dance within nature. Inside the sealed cabin, the operator sits surrounded by technology despite being in the forest. Air conditioning, electronic joysticks, computer screens displaying the length and diameter of each log segment. They control the levers by hand, but their eyes follow the trunk as it falls. No log is worthless. That is their philosophy: to utilize every inch, every wood fiber, so that no part of nature is wasted. This is also a silent respect for nature. As the first logs are stacked onto the trucks, their journey out of the forest begins. Workers use the hydraulic crane mounted behind the cabin to load the wood. With each grasp, the crane arm lifts several 100-kilogram logs, placing them precisely onto the trailer. Another employee walks around the vehicle, checking the balance, then uses chains and steel ratchet binders to secure the entire load. Forest roads are unpaved. The truck must travel slowly, maintaining an average speed of 15 to 20 km/h to prevent overturning. On many segments, with gradients steeper than 12%, drivers must use the air brake system and global differential lock to stabilize steering. This job demands high skill and absolute concentration, because a single slip or slight collision could damage the entire consignment, or worse, cause a serious accident. As the truck approaches the industrial zone, the forest gradually recedes. The scenery changes. Replacing the canopy and damp earth are steel fences, factories, and rows of smokestacks. In the distance, the sound of the sawmills echoes continuously. That is where the logs will be reborn. Our destination is Sierra Pacific Industries, or ESPI for short. Founded in 1949, it is one of the largest privately held forestry companies in the United States, and also a model for sustainable forest management. From a distance, the Sierra Pacific log yard looks like a miniature city, with tens of thousands of logs stacked on top of one another. As soon as each log is unloaded, it must be identified. As soon as each log is unloaded, it must be identified, sorted, and its data recorded. This information will follow it throughout the entire production process, ensuring complete traceability from the forest to the final product. When the wood leaves the storage yard, the first step in the processing procedure is debarking, a seemingly simple stage that significantly determines later cutting productivity and quality. The debarker here is a ring debarker. The sensor system precisely determines the diameter. Then hydraulic knives automatically press against the surface, stripping the bark in just a few seconds. When the machine is operating, you can see the bark being separated into coiled strips, falling onto the conveyor. The industrial vacuum system immediately collects this material and sends it to the grinding area. There, the bark is processed in two ways: ground down to produce landscape mulch, decorative ground cover, or burned in a biomass boiler to supply energy for the mill itself. After debarking, the wood is placed onto the conveyor and moved to the head rig, main saw. This is a massive bandsaw, with a blade over 15 meters long, moving at a speed exceeding 40 meters per second. The sound when it cuts through the wood is not as loud as one might imagine, but deep, resonant, and steady, like a mechanical breath, precisely shaving off each wood fiber. The entire cutting process is controlled from a sealed operating booth, where the controller monitors via a series of screens. They can instantly adjust the cutting direction or speed if they detect a deviation. This job demands absolute focus, because just a minor error could result in tens of cubic meters of wood being wasted.
The texture on the lumber,
Alongside the head rig, the mill also uses a curve saw system to process non-straight trunks. The machine uses sensors and directional oscillation to follow the natural curve of the log, allowing for the cutting of boards that maintain continuous grain, preventing cracking. As a result, the amount of discarded wood is significantly reduced compared to traditional sawing.
We have some at our house that are like 12 FOHC. How big of a log would that have to come out? Oh, I can 4x12, you can put it in 3 hard on it. That's big enough for 4x12.
After passing through the main saws, the log is divided into several sections. The core, cant, a thick square block of wood, used for refinement cutting in a later stage. The edges, flitches, rough boards still bearing bark edges, which will be sent through the edger. Chips and small fragments, transferred to the grinding system for recycling. All parts continue to slide along the conveyor, advancing into the edging and trimming lines, where the final form of the lumber gradually becomes clear. After the initial cut, the boards still have curved edges and rough surfaces. At this point, the edger machine receives and removes the excess material, creating sharp, parallel cuts. The excess wood is not discarded, but is ground into wood chips, which are used in the paper or biomass energy industries. Next, the straight edge boards move into the trimmer. If edging is the step of shaping the form, trimming is the step of defining the destiny. This system consists of dozens of saw blades positioned 2 feet apart. As the board moves through, only the necessary blades are activated, trimming precisely to the standard size. The finished lumber is then moved to the final grading line, where humans make the final decisions about the value of each product. Their job is to visually and manually inspect each board, comparing it against the standards set by the ALSC, American Lumber Standard Committee. This set of standards has been applied since the 1920s, regulating every factor that affects the load-bearing capacity and commercial value of the wood. The final step, but also the most delicate, is kiln drying. The boards are stacked in the kiln, where a system of sensors and software controls the temperature, humidity, and drying time specifically for each wood type. Some batches last over 10 days, with thousands of differential measurements recorded continuously. The wood doesn't just lose water, it is trained to become more stable and durable, resisting warping, cracking, and deformation when encountering different climates. After drying, the wood's color shifts to a light yellow. The grain becomes clearer, and the sound when tapped is more resonant. This is the sign of completion, ending a cycle from the forest to the mill for the wood. As the wood bundles leave the mill, they are more than just industrial goods. They are a statement from Sierra Pacific Industries, the harmonious blend of the American timber heritage and the power of modern technology, creating products that are both refined and sustainable, embodying the full value of the new era. The journey inside the mill has concluded, but the story of wood doesn't stop here. For those who wish to understand deeper, let's return together to the vast forest, where the logs begin their life. There, we will witness the professional skill of the loggers, alongside the powerful capacity of the machinery, all working with precision and respect for nature. Come on, let's start. If Sierra Pacific is the symbol of power and technology, then in the endlessly stretching New England forests, the story carries a different melody. Here, strength lies in patience, and technology merges with the human heartbeat. Britain Lumber is one of the few mills that has maintained a stable production scale, large enough to supply the market, yet small enough to retain a sense of craftsmanship. There are no automated conveyor systems here, like at Sierra Pacific. Thus, when the wood arrives at the mill, hydraulic log cranes and log loaders take on the task of unloading the wood and moving it into the workshop. Inside the mill, the sawing line consists of a main band saw, 2 gang saws, multiple blade saws, and a resaw, auxiliary saw. All are controlled from the central booth using a simple electromechanical mechanism, not a fully automated system. A large log is fed onto the central head rig saw carriage. The operator adjusts the cutting direction to extract the most desirable core section. Every operation must be perfectly coordinated and absolutely precise, because a single missed beat could cause the board to warp or split at any moment. When the round logs are turned into cants, square logs, they are transferred to the resaw machine. This machine consists of 5 horizontal bandsaw blades, cutting the square logs into boards with a thickness of about 1 inch and a width ranging from 4 to 12 inches. This is the critical stage for determining productivity and the wood recovery rate, demanding high precision and synchronized operation between humans and machinery. After being sawn, the boards are moved through the grading stage to determine the next processing direction. If the edges are already square, the boards go straight to the trim saw. If the edges are still rounded, they are routed through the edger. The edger is equipped with optimization scanning technology, which helps determine the precise cutting location to square up the rounded edges, both enhancing aesthetic appeal and improving wood recovery efficiency. Next, the trimmer operator grades the wood according to its quality level and cuts it to standard lengths. Finally, when the cutting process is complete, the boards are sorted one more time by width and stacked with spacer strips between the layers, known as sticker piles. These spacers allow for even air circulation during the drying process. The stacks of wood, 4 layers high, 3 layers deep, are then moved into the kiln to reduce moisture content, ensuring stability for the finished wood product. A highlight of Britain's production process is the ability to fully utilize wood waste. Slabs, edgings, or trimmings are all fed into the chipper to be shredded into wood chips, which are supplied to paper mills. Even sawdust and bark yield significant benefits by being used as ground cover and animal bedding in agriculture. Thanks to this, BLCO not only minimizes waste, but also creates economic value from byproducts, items that were seemingly worthless. Returning to the dried lumber, it is now moved through the planer, where steel touches wood one last time, planing the surface flat, smoothing the edges, and creating subtle patterns for walls, ceilings, or exterior siding. At the end of the line, workers inspect each board, sort it by grade, then stack, package, and label it. Everything is prepared to be shipped out, becoming the foundations, frameworks, or roofs for thousands of structures across the Northeast. From the main mill in Fairleigh, dozens of trucks depart daily, carrying products and the pride of those in the trade. Technology advances rapidly. Artificial intelligence is entering every field. But at Britain Lumber, modernity does not erase the past. Rather, it enriches tradition. In every board shipped out, the fingerprint of the craftsmen who have dedicated their lives to the trade remains. This is evidence that, in the age of machinery, humanity is still the center and the soul of the lumber industry. Now join me for the final destination on our journey, the northern Swedish sawmill, Dorataya Sag. Winter temperatures here can drop below 25 degrees C. Snow covers the forest for months, and trees grow so slowly that it takes 80 to 120 years to reach harvest size. It is this very harshness that creates Nordic wood, high density, fine grain, superior durability. A nearly perfect structure for high-end construction and furniture. When the wood arrives at the mill, it does not go straight into the saw. The entire log will pass through an electronic scale to measure its mass, length, and diameter. This is not only for quantity and volume control, but also a commitment to transparency and fairness for forest growers and suppliers. Each log, big or small, is recorded and identified. They are no longer inanimate tree trunks, but citizens preparing to embark on a new journey. After scaling, the logs slide along the conveyor to the primary sorting area. Similar logs are separated and slide into individual storage compartments, awaiting the forklift to move them to the main production line. Similar to other mills, the wood will go through the debarking stage to clean off dirt and any metal inside, substances that could affect the safety of the entire production line. The separated bark is sent straight to the biomass boiler, where it is burned and converted into thermal energy to power the mill itself. Nothing is thrown away. It is merely a different form of energy being reused within the same cycle. The next step is the hew saw, the heart of the entire Dorataya Sag system. Unlike the multi-stage sawing typical in the US, the hew saw requires only a single pass to transform a round log into finished boards. As the log enters, a laser sensor system scans its entire shape, creating a detailed 3D model, and the software immediately calculates the most high-efficiency cutting plan. In a matter of seconds, the log enters one end and emerges at the other as bright, flat, and uniform boards, as if they had been molded. Every cut is monitored and adjusted by the computer in real time, There are no superfluous operations, no wrong cuts, only the mechanical precision controlled by data. Amidst the conveyor belts and automatic systems, there is still one area that cannot be replaced by machines: the manual grading area. Here, the craftsmen stand along the running stream of lumber, their eyes scanning as fast as lightning. With just a glance, they can distinguish wood species, grade, color, and potential use. When they raise their hand and press a button, a blast of compressed air pushes the board to the corresponding storage bin. A small touch, but the result of years of experience and deep professional pride. Now the wood has shape, but it is not yet mature. Inside, its moisture content is still high. If left untreated, the wood will warp, crack, or even rot during long-term use. Therefore, the wood needs to go through the drying stage. The boards are stacked into piles, with thin wooden strips called stickers placed between each layer. These small gaps play a major role. They allow air to circulate evenly, ensuring the drying process is uniform and preventing pockets of moisture, dryness, or mold growth. The board stacks are moved by specialized vehicles into huge sealed kiln chambers, tight like steel vaults. Here, the temperature and humidity are precisely controlled by a system of sensors and computers. It is not too hot for the wood to crack, nor too cold for moisture to linger. For days, even weeks, hot air is continuously circulated by fans through every gap between the board layers. The water in the wood slowly evaporates and is vented out. When the process is complete, the moisture content in the boards reaches the standard 6 to 8%, stable enough to prevent long-term warping or shrinkage. The craftsmen call this the tempering stage. Just as steel needs fire to become strong, wood needs the kiln to become resilient. From the taiga forests of Russia to the sawmills in the US and the white snows of Northern Europe, the journey of wood is a long one, traversing space, time, and different philosophies. At Sierra Pacific, we saw the power of scale and industrial discipline, where the forest is not just harvested, but managed as a living asset. At Britain Lumber, we touch the soul of traditional carpentry, where precision lies not in the machine, but in the craftsman's feel and pride. And at Dorataya Sag, we witness the future of the Nordic timber industry, where machinery, biomass energy, and artificial intelligence merge into one system. These three worlds, seemingly different, meet at a common point: the spirit of respect for nature and labor. Whether using a bandsaw, a laser scanner, or the naked eye, humans are still doing the same thing, transforming wood into material, but without forgetting to preserve the soul of the forest. As this journey concludes, we realize that technology, no matter how modern, is only a tool. The true element that elevates a profession has always been the people and their attitude toward the natural world. Because, in the end, what we are preserving is not just perfect boards, but the enduring relationship between humanity and the forest. A relationship that has existed for thousands of years and, if cherished, will continue for thousands more. Pacific Northwest, the loggers begin their new workday. The steep, slippery forest terrain, with its gigantic trees, forces them to use an ancient skill, the springboard. This is a plank they attach to the trunk, creating a safe platform nearly 2 meters above the ground. This allows them to avoid the flared base of the tree, where the grain is twisted and prone to splintering. This technique originated in the 19th century and has since become a symbol of the American logger, skillful, courageous, and innovative. When the saw touches the wood, every movement unfolds like a geometry problem. First is the face cut, or notch. 2 cuts create an opening angle of approximately 70 degrees, 90 degrees. This determines the direction the tree will fall. Next is the back cut, performed on the opposite side of the face cut. The logger skillfully leaves a thin section of wood called the hinge. This hinge will guide the tree safely down, keeping it directed. Finally, they insert wedges into the saw cut. A small detail, but the culmination of experience. These plastic or wooden wedges widen the cut, prevent the saw blade from getting pinched, and simultaneously direct the tree to fall precisely as intended. Once the trees are felled, they are cut into segments and loaded onto specialized trucks. These are not ordinary flatbeds. They are designed to bear enormous payloads, with each truck capable of carrying between 25 to 30 tons of wood. The drivers are veterans of the transportation industry. They know exactly which gear to select before a slope appears, whether to let the engine roar or brake carefully to avoid brake fade halfway down a mountainside.
We're taking them up to Hull Oakses, and Nathan's going to bark them, and then they're going to run them back out on the chain, and Danny's going to set them off. And we're hauling them over to Philomath High School for Lily's forestry class, and we're going to buck them into 10-foot blocks.
As the convoy leaves the forest, we know the wood's journey has just begun. From here, the lumber will head to the Vaagen Brothers lumber mill, where it will be reborn in a new form.
Compliments of David Hull Tree Farms and Hull Oaks Lumber Company and H&B Logging. So if any of you folks show up at the Philomath Forestry's home competition on March 14th, you'll see these. Just setting 4 on, going to chain them down, and we're taking them up to Hull Oakses to the sawmill. And
Vaagen Bros. Lumber is a family business that has existed for over 70 years. Through the decades, they have witnessed the entire era of change in the American timber industry, from the axe to the chainsaw, and now to the age of computers and laser sensors. But no matter how much the technology has changed, the original spirit remains. It's not just about sawing wood, it's about understanding wood. When the truck stops in front of the gate, the gantry crane begins its work. It moves on the tracks above, lowering its pair of steel hooks, embracing the tens of tons of wood, and lifting the entire load effortlessly. In a matter of seconds, the entire truck is unloaded. Next, the merchandiser scans each log, recording its shape, curvature, and defects. The computer immediately analyzes and decides how many segments should this log be cut into, and what length is most optimal. This algorithm has replaced hours of manual, visual measurement, quickly providing the most productive and high-quality cutting plan. Subsequently, the logs are moved to the debarking area. Large metal rotating drums operate loudly, stripping away the rough outer bark, removing grit and soil. The bark is not discarded. It is collected to fuel the boiler, providing heat for the entire mill. Once the logs have been cleaned, they move into the main sawing area, the heart of the mill. Here, the hew saw cuts the round logs into squared blocks, called square cants. The saw blades are thin, spinning so fast that the naked eye only sees a blurry silver streak. The operator stands in a glass cabin, hands on the control panel, observing the screens. Although the computer does most of the work, their eyes never leave the wood. After cutting, the squared wood blocks, cants, are moved to the industrial kiln dryer. Here, steam, temperature, and time are controlled precisely down to the minute. Each batch of lumber is placed in the kiln for 3 to 5 days, depending on the wood species and initial moisture content. Hundreds of sensors monitor continuously. If the heat is too high, the wood can crack. If too low, the remaining moisture will cause it to warp later. In the past, people had to air dry wood outdoors for an entire season, watching the sun and rain, hoping for favorable weather. Now, everything is within reach. It is still a natural process, but guided by science. From the kilns, the boards are transferred to the planer mill. Here they pass through a series of steel knife heads rotating at over 10,000 revolutions per minute. All 4 faces of each board are quickly planed smooth, becoming as flat as glass. The technician stands at the end of the line, checking each board by hand. Although everything is measured by sensors, their fingers remain the ultimate gauge for confirming the wood's quality. Finally, the finished boards are gathered into bundles, securely fastened with steel or plastic strapping, and wrapped in a protective layer to ensure safety during transportation. Each bundle of wood will now be lifted onto rail cars and trucks, beginning a new journey, leaving the United States, heading toward various construction projects and homes across the world. Looking at it from a distance, the entire Vaagen Brothers production line operates like a living organism, rhythmic, precise, and efficient. But the most remarkable aspect is not the machinery itself, but the way humans and technology merge as one. Here, technology does not replace the human hand. It simply extends their capabilities, helping them perform better than before. Now, we will leave the cool, damp Washington state and head south, where the McDixon mill stands amidst the red earth, bearing the silhouette of a traditional industrial monument. This mill is not just a place where wood is sawn. It is a testament to how one family, across generations, has preserved a craft, a style of labor, and a simple belief that the true beauty of wood lies in how deeply man understands it. In the morning, trucks queue up at the mill gate. Each trip brings logs freshly harvested from the surrounding forests. The rotating crane slowly places each log down in the yard, where they will be sorted. The log yard manager has over 30 years of experience. A quick glance is enough to know which logs are suitable for beams, which are for furniture, and which are only suitable for pulp. From the sorting yard, the wood passes through the rotating drum debarker. The rough outer bark is stripped away, revealing the lighter colored grain within, raw yet full of potential. Immediately after, a 3D laser scanning system scans the length of the log. The display screen appears like a cross-sectional scan, showing every growth ring, every knot, and every hollow core. The computer system calculates the optimal cutting solution in mere seconds. That is the moment where science intervenes in art, and the two become one. After passing through the band mill, the log has now become squared wood blocks, called a cant. The core has been basically shaped, but to become a finished board, it needs a series of further steps. That is the task of the secondary cutting department. The cants are routed to the gang saw, where dozens of saw blades operate in parallel, splitting the wood block into multiple uniform boards in a single pass. From the gang saw, the boards continue through the edger to finalize their shape. Two vertical saw blades run parallel along both sides, removing the bark or uneven wood edges. Each board that passes through is scanned by sensors, precisely identifying where trimming is needed. Finally comes the trimmer, the standardized length cutting stage. Here, high-speed rotating saw blades trim each end of the board, ensuring every piece meets the standards of 8 foot, 10 foot, or 12 foot, depending on the intended use. The leftover wood ends are not discarded. They are collected to be chipped or ground into biofuel pellets, which McDixon uses to fire the drying kilns in the mill itself. After the trimming stage, the boards are moved to the bin sorter system. When a bin is full, a mechanical mechanism automatically opens the bottom, dropping the entire stack of boards onto the chain conveyor below. At the stacking stage, the automatic system intersperses each layer of boards with kiln sticks, or stickers. This is a small but crucial detail that allows air to circulate easily, ensuring that heat and moisture are evenly distributed throughout the lumber stack. From here, the log is transferred to the main sawing area, handled by the band mill. The saw blade is thin and long, like a ribbon of steel, spinning at extremely high speeds. This very design helps minimize wood loss. Each cut removes only a tiny amount. After stacking, the wood is transferred into the kiln dryer, massive sealed drying ovens. Inside, the temperature and humidity are strictly controlled by computers. This process lasts for several days, reducing the wood's moisture content to the ideal level, approximately 12 to 15%. At that level, the wood is dry enough not to warp, yet alive enough not to crack. The stacks of wood leaving the kiln are drier and lighter, but to become perfect products, they still must go through one more stage: planing. At McDixon, the planing area is located on the eastern edge of the mill, separate from the sawing and kiln areas. The atmosphere here is distinctly different, less dusty, brighter, and carrying the faint warm scent of dry wood. Each board is planed on all four sides: the top face, bottom face, and both edges. Every steel blade, hard as a samurai sword, shaves off a thin layer of just a few millimeters, just enough to smooth the surface without losing the natural structure of the wood grain. After planing, every board is scanned for size and flatness. The laser sensor system measures the error tolerance in just hundredths of a millimeter. Boards that do not meet the standard are removed for adjustment or replaning. Everything is recorded with a code number printed directly onto the board face, a testament to McDixon's rigorous quality control process. Finishing the planing process, the wood is blown clean of dust, sorted into stacks, and then sent through the automated grading and packaging system. A robotic arm gently lifts each board, places it onto a pallet, wraps it with a protective film, and prints a QR code label. The phrase McDixon Lumber since 1919 appears on every package, simple, yet carrying the weight of an entire century in the trade. Looking at the neatly stacked packages of lumber, no one would recognize them as the rough logs once found in the forest. Through many stages, cutting, drying, planing, they now take on a new form, clean, refined, ready to become house frames, flooring, or furniture all over the world. From the western forests, our journey continues to a new land. That is Woodmill, Latvia, the industrial pride of Northern Europe. Woodmill, Latvia was established in the early 21st century, when the Baltic region became a central supplier of biomass energy to Europe. This mill specializes in processing high-quality firewood, a seemingly simple product, but one that demands rigorous precision. Each log is fed into a poleaxe splitting machine from Finland. A sensor system quickly scans it, determines its size and curvature, and then hydraulic arms split it in half or quarters with nearly 20 tons of force. The split firewood then goes straight into the 3.5 Mega Sawmill industrial kiln dryer. Heat is generated from the bark, chips, and sawdust itself. For 3 days, sensors monitor the process minute by minute until the residual moisture content is only 15%. At this point, the firewood burns cleanly, without smoke or residue, meeting European standards for bioenergy. The mill operates year-round on a circular biomass heat supply with near zero emissions. From splitting to packaging, all data is digitized. On every bag of firewood shipped to Germany or Sweden is a QR code that records the entire journey. From the original forest to the kiln, that is the hallmark of the Nordic spirit. Not just doing it right, but doing it precisely down to the last detail. From the old-growth forests of Oregon to the mill in Latvia, the journey of wood is the journey of humanity itself, moving from the crude to the refined, from muscle power to the intelligence of machinery. But no matter where we are, whether in an American forest or a European plain, one constant remains. Wood always carries the breath of human endeavor.